All right, guys, welcome to Math Analysis on April 3rd, I think. What we're going to be doing is these two problems, number 8 and 9, on that first page of your packet. We're going to do these entirely together using some of the stuff that we learned, or at least talked about and reviewed yesterday. So, yesterday we talked about how to rewrite these square-rooted or radicaled variables as having fractional exponents. So that's going to be what we want to do first today, and then we'll take those fractional exponents and we'll work towards making derivatives with them. So whenever I have radical variables in my equations, I like to just rewrite them right off the bat. So if you're unsure how I'm making this transition, check out the video from yesterday. It'll go over it in pretty good detail, I think. So we have x to the 1/6 minus 7 x to the 1/4 plus 3. And here, we don't have a number right there, but as you guys probably know, if we don't have a number, then we presume it is a square root or a 2, right? So 3x to the 1/2. Okay, so we get this. Now what we want to do is we have a derivative that is, or a function that can be turned into a derivative using the exact same rules as we always have. So even though there are fractional exponents, it still operates the same way. So you'll see what I mean here. So the coefficient here, which would be a 1 since we don't have anything written, multiplies this. So 1 times 1/6 would give us 1/6. And then we have x, and if you recall, what we do is we take 1 away. We go 1 lower. We subtract 1, however you want to say it. So it gets a little complex thinking about it with fractions, but quite literally, if you just subtract 1, even if you just do it in the calculator, you get what our new exponent should be. So 1/6 minus 1 is negative 5/6. Okay? Now we're going to do the same thing here. We have negative 7 times 1/4. Well, negative 7 times 1/4 is going to be negative 7/4. And then if you subtract 1 from 1/4, you get negative 3/4. Now, we have our final one here. We have 3 times 1/2. 3 times 1/2 is 3/2, or 3/2. And then we go 1 less on the 1/2 for our exponent. And 1/2 minus 1 is negative 1/2. So our derivative to the function is this right here. Apologies for the oven going off. I thought I got that turned off a minute ago, but I was unsuccessful. So this is our derivative. As kind of weird as it looks, having all of those fractions and, well, rational exponents as we call them, that kind of stuff. But it is, in fact, what we're looking at for our derivative there. And if we wanted to find the derivative for a certain value of x, we could plug it in just like anything else. Let's go ahead and take a look at number 9. We'll find the derivative of this one as well. So I'm going to start by doing the same thing, taking all of my radical variables and rewriting them as rational exponents, or fractional exponents, whatever term you want to use. So we have 7, and then we have 9 and 4 here. So that's going to be x to the 4/9 power. Then here we have minus 2, and then I'm going to be honest, I don't know why the worksheet has a 2 right there, because as we said in the last problem, if there's nothing there, you just presume it's a 2, so we didn't need to write that, but for whatever reason they did. And we get x to the 7/2 power. We had a comment on yesterday's video about, can we get an exponent that is greater than 1, or, you know, an improper fraction, I suppose you would say. And this is an example showing we absolutely can. It's very possible for it to be a fraction greater than 1. And then here we have 4 and 3, so we get x to the 4/3 power. Now, if we want to go ahead and take the next step to find the derivative of it, what we're going to do is multiply our coefficient times our fraction. Now, 7 times 4/9, that's going to require a little bit of thought. So 7 times 4 is 28. So it would be 28 over 9, x, and then 4/9 minus 1 will be negative 5/9. Okay, next up, we have 2 times 7 over 2. Well, 2 times 7 over 2 is 14 over 2, or that just simplifies to 7. And then we have x. We subtract 1 from this. So subtracting 1 from 7 over 2 is going to get us 5 over 2. I don't have my calculator with me. I think that is right, and I really hope I'm not leading you all astray on that, but I'm confident. I'm confident. Now we have x to the 4/3. Our coefficient is just 1, so it becomes that 4/3. And then we take 1 away from this, and taking 1 away from 4/3 is going to give us 1/3. I know that subtracting these fractions in some cases can be a little bit difficult just for the mental math side of things. So by all means, use a calculator on those if you're unsure. And even if your calculator turns it into a decimal, then you can just hit the fraction to decimal button on your calculator, and it will turn it into that fraction that we would be wanting to use in the derivative problem. So this is 8 and 9. We are going to continue on with the packet on Monday, but I just wanted to go over and talk about these kind of radicalized variables, or the ones under the roots. So yeah, if you have any questions, send them my way, but otherwise, I'll see you Monday.